everybody. My name is Abdullah Mahmood, and this is my submission for Physics 2211, Lab 01, Section W21. All right, so an introduction to the experiment. So we were tasked with rolling a marker across a yardstick, and the purpose for this was to observe an object, which in this case was the marker, going at a constant velocity. And the reason was we did this was so we can compare the motion observed from the marker with a computational model, which will be through GlowScript. And now for the physics behind the experiment, we use Newton's first law, which is an object at rest remains at rest and an object at motion remains in motion unless acted upon by an outside force. So in this case, the marker will be at rest and it will be acted upon by an outside force, which will be our finger pushing the marker across the table. And then we have Newton's second law, which is the change of motion of the marker is proportional to the magnitude applied on it. Next, we have two update formulas, which is the first one being the position update formula, which is R final equals R initial plus V average times delta t. And then we have the velocity update formula, which is Vt equals Vo plus acceleration times time. Then we have the system and surroundings. And in this case, the system will be the marker and the surrounding is the table and the meter stick. Okay, so this is the lab experiment that we did. We took the video of it and then we input it into Tracker and we go ahead and play it so you guys can see. As you see, as we roll the marker along, we gathered all the data points necessary, required. We got the time and the X values. And then it stops right around the 51-inch mark right over here. And one thing I would like to point out is that the graph looks like it's going into the negative X direction when it should be going up, sorry, not up, towards the right in the positive X direction. And the reason why that is because we took the video flipped. So as you can see, the marker is going to the negative X direction. So what we did, we just took the inverse of all of our X values, and then that's how we got our graph to be how it is. It's going in the positive X direction. Code that we use for the experiment, and this is just the starter code, but we modified a few things. So the first thing that we modified was the delta t, which we changed to 0.033 seconds, and that is the master frame rate in Tracker. Next, we changed the time to be less than 3.27 seconds because that's how long the experiment lasted for. Then we changed we updated the marker's position with this formula, which is 1.24 divided by 3.27 times the delta t. The reason why we did this is because 1.24, that's the length of how far the marker traveled, and it was 1.24 meters. Then we divided that by 3.27, which is how long the experiment lasted for. Then we multiplied that by delta t, which is 0.33. And we set it like this because it will be able to accurately update the marker's position over time. And to show you guys, I'll run the program. And as you can see, our position versus time is constant. And so is our velocity, which is also constant. Here's the computational comparison model. And the blue line, that is our GlowScript data, and the red line, that is our tracker data. And as you can see with the tracker data, it is not constant, and that's because of many things at play, such as friction from the table and the marker, air resistance, and a whole bunch of things. You can't really have constant motion in the real world, but with GlowScript, since it's a simulation device, we can have constant motion, and that is why you can see that it is a straight smooth line, meaning constant, and the tracker data, which is not as constant as our GlowScript data. Now, what if we flip the x-axis? The data will remain the same, however, produce a negative slope as shown in the tracker video. So remember from earlier on in the video when I showed you the tracker experiment and how the graph produced a negative slope, and that was mainly because we had the video flipped. But that's how it would look like if we had flipped the x-axis. And also the magnitude will remain the same since the negative values are just turn the positive ones. And because of that, the rate of change will also remain the same. So what does this mean? Can we find the net forces? No, not necessarily. As stated many times beforehand, there are too many variables at play, such as friction, air resistance, gravity, etc. These all have a play on the marker. But we can still, however, find the net forces in a computational model, for example, since we can set the variables to how we want it to be. Now for errors, some errors I probably did is like I didn't properly calibrate the axis origin calibration stick in tracker. That's mainly because the video was moving. You can't really set it all that well while the video is moving. And there's probably some potential error in the code that I missed. And also, as I said before, outside forces, air resistance, gravity, whatnot. Well, that is all for my lab video. Thank you all for watching. Make sure you guys hit that like button and subscribe for more.